Hi, my name is Jack Wickstrom, and this is my EE1301 Intro to Computing Systems individual project. This is through the University of Minnesota, and the professor teaching this course is Faisal Kaleem. The project that I decided to do was actually a combination of 4 different projects that we did some work on throughout the lab portion of this course. And those 4 projects are the LCD display, the temperature reader, the brightness reader, and the buzzer. And I chose these 4 projects because I enjoyed working on them and I felt like I could expand on them from what we did in class. Because a lot of the time we didn't have a lot of room for improvement. Like we wouldn't have time during class, and then with the busy schedule I didn't have time to keep working on those. But for this project I knew that I needed to allot time for working on something with the Arduino board, and so I decided to continue these because I had interest in continuing these 4 projects. The first of the projects I'd like to talk about is the LCD display. So this is just a display that goes on top of the Arduino, or connects to the Arduino on top of the breadboard, and it is 2 rows and 15 columns wide, so you can put up to 32 characters on that display. And this display you can either hardwire in or hardcode in what you want it to say. For example, hello, my name is Jack. Or you can have it display variables that you're reading. So for this I have a combination of both. The one that we did in class, we did a voltage reader. So we set up a circuit and we had a voltage divider, and we had a pin connected to the Arduino that would measure the voltage. For this one I actually have it hooked up to the temperature sensor to combine them. But it's so that's what the LCD is, and this is some of the sample code that's used. The important thing is the top part, the include LCD or liquid crystal.h. That is the function that the Arduino needs in order to have all this work. And then almost everything down here that you can see in this setup is what's important, is the serial, or not the serial, the LCD.begin and the LCD.clear. So this LCD.begin defines the maximum range of the LCD display. Now ours isn't quite 2 by 20, it's 2 by 15 like I said earlier, but it's good to have the code as bigger so that you can write things and it doesn't get confused when you set it up for smaller than the actual display is. And then LCD.clear clears the screen so that it'll input nothing on it, which is important because you don't want, when you're trying to display something, having it overlay with what you last displayed on it. And then set cursor, what it does is it sets it at the upper left hand corner, 0, 0. And then LCD.print is what it uses in order to write on there. And so I have it set up for this demo as current temp equals, because what I wanted to do, like I said, was connect it to the temperature reader. And so I figured that a good way to do that was have it say current temp equals. Oh, and then the second row, I have it so x is 0, y is 1, and I have it just as an empty brackets, and that sets it equal, or sets it blank. So if there was writing on the second row, this would erase it. The second code that I'd like to talk about is the temperature reader. Now, we did this one in class, and this is the example of the code that we did in class, and I've actually modified this for the project that I'm using today, for the demo. But the code that I like to talk about, like I said, is the one that we used in class. And I think the major difference is the fact that this prints to the serial port, and the one that I have connected up to my board connects to the LCD display. And it's not a huge change, but it's one that I wanted to do to kind of make my project more coherent. And so what this does, if I can just get this code a little bit, is there's not much setup. What it does is in the serial port, it just prints out the thermometer, and so the LM35 is the name of the actual transistor that we're using in order to measure the temperature reading. And then the analog reference internal makes it so that it references the internal part, like it says, pretty self-explanatory. Then what we have after that is a function, print tenths, and so what this does is, as it's called later, and what it says is it prints a value of 123 as 12.3, and this is because the temperature reader obviously does not read just in degrees Fahrenheit. it reads in values. And so this is a transistor. It doesn't know how to convert, let's say 500 into what its equivalent in Celsius would be. So we need to do conversions, and I'll get to that later. But this one is what converts it again. So the first time that we're going to do it, we convert it to a number of Celsius times 10, and so then this, all that it does is it divides the value by 10, and it prints it out in the serial monitor. So then if we go over to the loop, what this does is it analog reads at the temperature of the transistor, and what it does is it performs conversions. So if you look over there, temperature equals 100 times 1.1 times A read divided by 1024 times 10. So that's obviously a lot of stuff that doesn't really make sense, but what it's doing is, as it says below, it's converting the voltage to a temperature. So this transistor is measuring the voltage drop due to the temperature of the room. And so what this does then is it does this conversion, all this multiplication, and what that ends up giving you is like I said, a number 10 times the degrees Celsius of the room. And this can be found out by knowing the temperature of the room and then figuring out what it's reading, and you can actually do this by taking several points. And this is a conversion that was given to us. There's a different time in which for the light sensor, you'll see that the conversion actually has to be made by hand. And so this one isn't too bad. And then the last part of the void is the calculated temp. So what it'll read in the serial port is the calculated temp, and then it'll say what the calculated temp is in degrees Celsius. And then the delay of 500 milliseconds is so that it doesn't, completely fill up your screen, immediately. It gives half a second delay in between each time it reads the temperature, which is still fairly fast, but it does give a little time for change. The third project I'd like to talk about is the brightness. So this is the one that I was talking about. This is the light sensor. The resistor that we're using is a light resistor, and what that does is it measures the light in the room and it converts that into a voltage that it allows across the resistor. And then we can measure that voltage, and just like we did with the temperature, we can convert that voltage into a reading that we can understand as the brightness of the room. And so as you can see over on the right, what we did is we took 6 points and I measured the value of them. The y-axis is an approximate centimeters, but my hand was away from the light source, or from the resistor, and then the bottom part is the converted value given out, the voltage given out from the Arduino. And now what I did is I used a logarithmic conversion in order to get this into a linear graph, because it's much easier to work with a linear graph when trying to do a conversion in the Arduino language. So what we did is I actually used Excel for this, and I just made a graph, and then I plotted the graph, and it was a curve, and then I used the logarithmic transformation to turn it into a linear graph, which is much easier to work with. So then, as you can see here, distance. So what this program actually does is, it's not the one that I used, but it's the one, like I said, this is the one that we used in class, and then I modified it. And so this measures the distance approximately that your hand is away from the light source. And so, like I said, I moved my hand distance away and I measured the value. And so what I did using this equation then is I can put my hand over the resistor, and I can move it up and down, and it'll give me different values of how far away my hand is in centimeters, and with a 1 second delay in between. And so this is nice because it allows, it's not all that accurate because of the tools that we were given, but it is nice to see that we can do this conversion by hand, and given just an Arduino board and a light sensor, we can get an approximate distance. And it's cool to think about how we can use what we're given, something about source of light, and convert that into distance. And just how in this technology age, how given one thing, we can really make 1,000 more things out of that seemingly simple device. The last code that I like to talk about is the buzzer. So this is a piezo buzzer, and so it's fairly limited in the sounds that it can make. But what I decided to do was create a tone, make it play a song whenever a certain condition was met. And so this is the sample code again, the one that we worked with in class. And so the important thing here is the character notes and the int beats, which are up there. And so the character notes, what that does is it's telling the Arduino what string of notes that you actually want to play. And so this song is Happy Birthday, or Twinkle Twinkle Little Star, however you want to think of it. And so the notes on a keyboard, on a piano, or C, C, G, G, A, A, etc. And so what this will do is we define the character names down here as tones, which are recognized by the board. So this C as a frequency that the computer recognizes as 1915, and then the D is 1700, and so on. And so given these conversions, we can type in up there in the notes whatever tune we want it to play up to a certain degree. Like I said, it's not all that, it's pretty robotic, it's not very musical, but it's still kind of cool to hear a familiar melody. And the one that I actually chose for later is High Cross Buns, because I figured that would be a fairly simple melody that a lot of people would recognize. The next part that I said was important was the beats. And so what that does is it gives a value for how long each of the notes is going to be, for how long each beat, each note is going to take up. So for example, here you can see that most of them are the same length. Because if you start to hum Twinkle Twinkle Little Star, I'm not going to do it for you because my voice is terrible, but you can know that, or you can recognize that almost all of the notes are the same length except for a couple of them, which are up there by the different numbers other than 1. And so this actually makes it more musical, because otherwise it would just be a string of notes, right, all the same right after each other. But now it can do an actual melody with varying note lengths. So there's not too much else that I want to say about this. We're just calling, this is play note, and we're just calling the note through this, we're calling this function. And then, well, I guess the one thing that I do have is over here, delay tempo divided by 2. So we define tempo as 300. And so what you can do with that is you can delay the time in between each notes. So as tempo varies within actual music, so we can vary that as well. So we could either change that by changing the tempo, or we could change it over there and say that the delay is either just the tempo, or that the delay is tempo divided by 4, or however we want it, but that would change the time in between each of the notes. So then that brings me to the combinations. I sort of mentioned them peppered out throughout that, but what I did is I have the temperature reader, the temperature transistor transmits the temperature onto the LCD display. And then the other one that I have is the light value is what triggers the buzzer. I said that something triggers the buzzer, and I have at a certain brightness, that given a certain brightness of the resistor, the buzzer will be triggered to play Hot Cross Buns. So the code that I use, this is the actual code that is programmed onto my Arduino right now. And so you can see that a lot of it is very similar to the code that I showed you before. Some of the key differences, the length, notes, and beats. So this is the buzzer one that I'm pointing out. And so what it's doing here is these are the different notes for Hot Cross Buns, and then all of the different lengths of the notes. And so you'll be able to hear that the notes are varying in length. And the tempo I kept the same just because I felt like it was a fairly good tempo for Hot Cross Buns. A lot of it is very similar. I have here that the LCD display is set up to display current temp in the setup, so when we turn it on, it will automatically say that. Like I said, a lot of this other stuff is very similar. I have the print tenths again, so it divides the value by 10 to get an actual value in Celsius. Duration and note are both from the buzzer. And then here's the loop. And so the loop is a combination of all the things going through. So this is the temperature conversion, and I commented out the conversion to the serial port because I decided, I was debating whether to use it or not, but I decided that it would be better to just have it on the LCD display. This is the light value, and this is the distance formula that I talked about using the Excel and the graph. And then this is the light val. So this is the if statement with the light val. If the light value that's given is over 600, what it'll do is it'll use that to trigger this play the notes. So it's kind of cut off. I'm going to flip over to the next slide, which hopefully show more of it. So this is the loop function for the buzzer. So this is if the light value is a certain value for this, I have it set up at 600. What it'll do is it'll play the melody that I have set up, which is the melody of hot cross buns. And so again, this is the tempo, and then this is the end of the loop with a delay of half a second in order for the whole program to restart, and then it'll take the temperature again, and it'll see if the light value is over 600, and if so, it'll play the melody again, and if not, then it'll just keep going through forever and ever. So this is my board, this is my setup. As I talked about, there are pretty much 4 distinct parts, and then the actual Arduino. So this is the LCD display, which I hope you noticed right away, kind of big and in the middle. This over here is the piezo buzzer. This is the transistor that measures heat, and this is the light resistor. And then obviously this is my Arduino that has everything hooked up to it. Top rail is just power and ground, and then all the other wires are just making things work. So here is the LCD display. As if I move the wires, hopefully you can see it says current temp equal. As you can see, it's fluctuating slightly, and that's because the temperature in the room is hopefully fairly constant. But if I actually move in and I breathe on the transistor, hopefully it'll heat up a little bit. So you can see it went from 23 up all the way to 24.5, and so again, it's not the most accurate way to describe temperature, to measure it, but it is a fairly good way given the tools we have. It is fairly accurate, and it works really well. Again, these temperatures are in Celsius. The conversion would be fairly easy. All you'd have to do is take whatever the computer is inputting in for degrees Celsius and multiply it by 9/5 plus 32. So that'd be a fairly easy conversion, but for this I decided to leave it in Celsius. The second major function of this demo is the light sensor that triggers the buzzer. So if I actually put my hand over the light sensor, what it'll hopefully do is it'll eventually go and it'll make the buzzer start playing. So let's see, sometimes it's a little bit finicky, but we'll see if I cover it up. There we go. So this is the tune, hopefully you recognize as Hot Cross Buns. So we'll keep my hand here, we'll see if it'll play it again, hopefully it will. And so this is just, if I put it back over, when it's dark enough, when I cover up the light enough, it eventually plays the Hot Cross Buns. It's a little bit weird because I calibrated the light sensor in a room different than this, so the equation isn't quite right for calculating the light value, but again it works fairly well, and it still works pretty much on command. So there's Hot Cross Buns for you when I cover up the light sensor. Thanks for watching my video. I hope you enjoyed all the things that I showed here today. I know the class was a lot of fun, and if you're watching this debating about whether to take this class or not, I'd absolutely recommend it. Thank you.